Good morning everyone. My name is Mujilarasan Subramanian from University Technical Malaysia Melaka. So today my topic about voltage and current division method and equivalent resistance including wye-delta conversion. So first of all, introduction. Kirchhoff voltage law states the algebraic sum of the voltage in a loop must equal 0. So a practical application on this Ohm's law is the voltage divider rule. So second is Kirchhoff current law states the algebraic sum of all current entering and exiting node must equal 0. So the practical application of this law is current divider rule. Then the parallel circuit acts as a current divider as the current divides in all the branches in a parallel circuit, which in series circuit acts as a voltage divider as the voltage divides in the branches in a series circuit. Okay, so what is voltage divider rule? Voltage divider rule is calculate equivalent resistance in series circuit. So the formula for R request is R1 plus R2 plus R3 is equals to the branches how much. So then calculate current by applying Ohm's law, like I equals to V over R request. I is current, V is the voltage. Then current remains same in series, like IS is equals to I1 and I1 is equals to I2, I2 is equals to I3, following like that. Then as voltage divider in series, so voltage divider rule state that Vx equals to V times Rx over Rx plus Ry plus Rz. So the next slide will be the example of voltage divider circuit. Okay, here we want to do an example of voltage divider rule. So this is a simple series circuit which have 3 resistance and 1 voltage. So first of all we have to do find R total, like 5 plus 10 plus 7.5, so is 22.5 kilo ohm. Then we have to find V1. So the resistance given at V1 is 5 kilo ohm. So the formula is R1 over R total times 45. So 5 over 22.5 times 45. So the answer is 10 volt. Then the second 10 over 22.5 times 45. So the voltage for V2 is 20 voltage. For then the R3 is 7.5 over 22.5 times 45. The answer is 15 voltage. So here we can prove our answer. So Vs equals to V1 plus V2 plus V3. So 10 plus 20 plus 50 is 45 voltage. So it's proof our answer. We have kept same answer. That's all. So the next slide is what is application for voltage divider. Voltage divider is used only there where the voltage is regulated by dropping a particular voltage in a circuit. Mainly used in such system where energy efficiency does not necessary to be considered seriously. And then in our daily life, mostly commonly the voltage divider is used in potential meter. Then the best example for potential meter are the volume turning knob attached to our music system and resistor and etc. Okay, next we will see about current divider rule. Current divider rule is calculate equivalent resistance in parallel circuit. So the formula is quite different from voltage divider rule. So for this R request is R1 times R2 times R3 over R1 plus R3 plus R1 plus R3 plus R2 times R1. Okay, the Ohm's law for current divider rule is I equals to V over R request that we find first. For the voltage divider rule is I current is equal same, but in voltage remain in current divider rule is voltage are same remaining, like V1 equals to V2 equal to V3 is equal to V total, it means Vs. Okay, so the parallel circuit for current dividers is rule is Ix equals to RT over Rx times I. So we can see the next slide, we can see the calculation for current divider rule. Okay, so this is current division method. So this is a simple parallel circuit with R1 and R2 and RT. So R1 is 1 kilonewton, R2 is 3 kilonewton, and R3 is 2 kilonewton. So the voltage is 6 voltage. Okay, first of all we have to find R request, which means R1 over R1 plus 1 over R2 plus 1 over R3. So the total R request is 0.54 ohm. So then we have to find Is. So its formula is V over R request. So the Is is 11.11 ampere. So the second is we have to find I1, which at R1. So R request over R1 times Is. So 0.54 over 1 times 11.11 ampere. So the answer is 6 ampere. So the second I2 0.54 over 3 times 11.11. So the I2 is 2 ampere. So the other is R3. So 0.54 over 2 times 11.11. So the I3 is 2.97. So we can prove also we plus 6 plus 2.7 plus 2 is we get 11.11. Thank you. Okay, now we can see the application of current divider rules. So in real life we can see the current divider circuit at electric meter circuit, where a friction of measure current is desired to be rotated through a sensitive detective device. Then using the current divider formula through the proper shunt resistor can be sized to proportion just the right amount of current for the device in any given instant. Okay, now I want to explain about wye-delta conversion. So here inside we have two pictures. So the left hand side is delta connection and the right hand side is Y connection. So here the formula for find delta connection to Y connection is RA is equals to RAB times RAC over RAB plus RAC plus RBC. So RB and RC is the same like that. So like RB is RAB times RBC over RAB plus RAC plus RBC. Then we can see the RC is RAC times RBC over RAB plus RAC plus RBC. So in my right hand side we can see the Y connection to the delta connection. So the formula for RAB is equals to RAB times RB plus RA times RC plus RB times RC over RC. Then RBC is RAB times plus RA times RC plus RB times RC over RA. Then RAC is RA times RB plus RA times RC plus RB times RC over RB. That's a formula for this section. Okay, now so So we can see the advantage and disadvantage of wye-delta configuration. So first of all, we see advantage. Number one is the primary site star connection. Star connected means the Y connected, hence fewer number of turns are required. This make the connection economical. Then the neutral available on the primary can be urged to avoid distortion. Then large unbalanced loads can be handled satisfactorily. So the last slide for today is about disadvantage of Y and delta conversion. So number one is the secondary voltage is not in phase with the primary, like 30 angle phase difference. The second is, hence it is not possible to operate this connection in parallel with stars or Y or delta connected to transform. So from this video I study about the Y and delta connection and current divider, voltage divider. I have knowledge about that. Thank you very much.